Hello everybody, I just wanted to do a quick tutorial on how to do at least two of the problems from the lesson that we will see tomorrow. I'm not going to be there tomorrow or today, depending on when you're watching this. So I just wanted to give you a little bit of a hint here. We are continuing our study of polynomials, and as you can see here, we have a problem where somebody has created an equation. As you can see, we have an equation of two linear factors and a quadratic factor, x plus 3 times x plus 1 times x minus 1 squared. And they are wondering whether this graph over here represents the right thing. I will let you think about how you can decide how to tell if the equation presents the graph correctly or not. I will tell you that it does not, and I'll let you decide how you want to. And the reason why it does not is because we need a stretch factor, and that's what part B is getting at here. Before you figure it out, you could have written the polynomial for this graph as, and here we have that expression. Notice that there's an A here. Notice that there's an A. You probably have seen an A like that before. We call that a stretch factor. And also, they tell you that we have a point 1, 16. Now, we can't see it on the graph here. I mean, you can kind of see it, but it's kind of hard to tell that that's 1, 16. So thankfully, they give us this point. Now, why will we use this point? Well, we have an unknown value here for the stretch factor, but thankfully we have an x coordinate here and then a y coordinate. So we're going to use those two things to find the stretch factor. And I'll do it really fast for us so that we can move on to the next problem. I don't want to make this video too long. So when x is 1, y is 16. That's what that point says. So let me replace the p of x with 16. Okay, and then I will have my a. X will be replaced with 1 because of that right there. So let's replace this with 1 plus 3 times 1 plus 1 times 1 minus 2 squared. And I think you can probably do the rest. But let me do it here real quick. We have 4 times 2 times negative 1 squared. 16 equals a times 8. All right. The negative value goes away there because negative 1 squared is just 1. So we should have a equals 2, right? And so our more accurate representation of the graph that we have up here will be the polynomial with the factored equation of p of x, and I don't like using capital letters here, but that's okay. We'll just do it for the sake of this exercise. X plus 3 times x plus 1, x minus 1 quantity squared, right? So we have two linear factors right here, and then our quadratic factor. And notice you can see the two linear factors crossing right there, and then the quadratic factor with a multiplicity of 2, if you will. A multiplicity of 2. So that's nice. It gives us a better way to write a more accurate polynomial based on the information that we have. And it's nice that they gave us a point here, but they won't, and they also gave us an equation here, but they won't always do that. Well, actually, they won't always do that, and then the problems that you will do today, you will figure out how you can do it. This problem here, the county fair coaster ride, kind of hints at how you do it without a graph. Okay. I will let you read this situation. As you can see, there's some stuff happening. you have more expertise with polynomials, and so let's apply them now. If I can scroll down, let me see. I can't. Apparently, I can't scroll down. I don't know what just happened. There we go. That's better. Okay. So here we have another graph. The numbers along the x-axis are in hundreds of feet. Okay, keep that in mind. At 250 feet, the track will be 20 feet below the surface. That gives us a point of that. All right, this kind of walks us to what we ought to do when all we have is a graph. We don't have an equation. We have to come up with that equation, right? Notice in this previous problem, they were nice enough to give us an equation. Now we will have to extrapolate an equation from this graph here. Thankfully, they kind of walk us through how to do it. And so later on, when you don't have any information, I would suggest that you use these steps to come up with an equation. So notice how the first problem here says, what is the degree of the polynomial? Both endpoints are going up, right? So we know it has to be an even degree, It crosses the x-axis right here. It's got a double root here, and then it crosses there again, right? So that means we have one root here, two there. So that makes 1, 2, so that makes 3, and then another one there. So we have 4 roots. And thankfully, there's nothing weird about this one. We're not getting into complex numbers or anything like that. So the degree of this polynomial will be 4. Okay? The degree, let me write this nicely. Degree is 4. Okay, that will help us a lot with the equation. What are the roots? The roots will also help us. Notice we have a root at x equals 0, x equals 2, and x equals 3. So our roots will be 0, 2, with a double root there, and 3. Okay, so since we have roots at 0, 2, and 3, remember, if x equals 2 is a solution, then x minus 2, oopsie daisy, I wrote that wrong, then x minus 2 is a factor. And because this has a double root, we can square that factor. So that really helps us to come up with an equation, doesn't it? We have another root at 3, and if 3 is a solution, then x minus 3 must be a factor. And if 0 is a solution, then that means x is a solution. Or sorry, it's a factor. We can talk about this when I come back to the classroom sometime, on Monday. So we have our equation y equals, now we have a stretch factor. Don't forget the stretch factor. And here is a potential equation, right? And does it have the degree that we're looking for? Well, we have x there. This will be x squared, so 3x to the third power once we multiply all of this out, and x to the fourth. Yep, that looks like we have the right degree that we need. Okay, find the exact equation for the polynomial that will generate the curve. Okay, now this could be, well, without the a, we won't know whether there's a stretch factor or not unless we choose a point. I can't see a nice point on there. You don't want to choose the roots because the roots are not good. It seems to me that there is no stretching going on, so the stretch factor here probably is 1, so y equals x times x minus 2 squared x minus 3 times x minus 3. That's probably the equation that models this, and you can verify it by plugging it into your calculator. Plugging it into Desmos probably would be easiest. Now, in the next few problems, they will actually, they are not going to give you, they will give you, sorry, I'm trying to remember what the problems look like without going to look at them. But in the next few problems, they will actually give you some points, some roots. They will ask you to come up with an equation, kind of like what we did here. And then they will ask you to find the stretch factor, similar to how we did it on the first problem, which I am sure all of you, or hopefully all of you, have seen before. This is just taking it a step further, right? Now we are coming up with potential equations. The degree is very important. The degree is very important when we want to come, the degree and the roots. Those two pieces of information are very important when we want to come up with equations. Just remember that if we have solutions or roots at some number, that means, like, if, I don't know what happened there. Let me scroll down. If n is a solution to f of x, meaning f of n equals 0, then x minus n is a factor. This is a theorem. I can't remember the name of this theorem, but use this theorem to come up with factors for your polynomials. And good luck, folks. I will see you on Monday. If you have any questions, feel free to email me. I left the answers with the subs so that you can check your answers. And I will talk to you later.